believe that we have time for a few questions. So if any one of the attendees has a question for any of the panelists are all here. So if anyone have a question, please use a Q&A or raise your hand and we will let you unmute yourself to ask the question. So I believe someone from here has a question.
Yeah, hi. Probably Julio. Okay, yeah, you're muted. Fine. Because we are very close, almost. Well, we are in the same room, so I didn't want any echo to sound. I have a question for Sarah and the DFA method, which
Yes,
I really liked. I remember I tried too many years probably ago to work on with that method. I was wondering, in your experience, was it difficult to tune? Like, is this a learning algorithm that runs out of the box? Like, I mean, with backprop, you have hyperparameters like in the optimizer, but you have also now an understanding of how to set those hyperparameters. While every time I work with something which is more bio-inspired, I always struggle with the choice of the hyperparameters, which often are many, right? So I was just wondering, what's your take on it and your practical experience working with it?
Thank you for your question. And no, in my case, I was lucky. I just found on GitHub a package implementing DFA. And the only parameters I can tune are the learning rate, which was very easy to set. It's just one order of magnitude larger than BP, and the feedback matrix variance at the initialization. It is true that biologically plausible algorithm can be hard to make work or to set, but this one was fine. The package is called TinyDFA.
Okay, thanks. No,
yeah.
It's nice to see that the community has advanced and made it easy to work with it. Thanks.
Thank you.
So I don't see any question from the attendees. Maybe I have a question, maybe both for Rudy and for Sharon, given that both talk were kind of a HPO directed presentation. So first, maybe Sharon can answer, but the question is, have you figured out the interpretation of the similarity of the task when changing the hyperparameters in the sequence? For example, I imagine that if a task 1 is very similar to a task 2, the hyperparameters shouldn't move so much. However, on the other hand, if you have a task 1 very similar to a task 2, hyperparameters, I imagine, should change. I don't know if you have seen this situation. Yeah, go ahead, sir.
Sorry. I actually received the similar question from the chat. Our initial experiments showed that the HPO process itself is able to determine the task similarity by, for example, lowering or highering the regularization strength in our case, in our first experiments, if the task is dissimilar or similar. But in our current approach, we are not measuring any task similarity right now. But as I said in the chat, this is very exciting future direction for us to investigate and optimize even better our search space.
Yeah, more or less is the similar answer. Not directly, but by empirically, I noted that essentially, for example, for rotating NIST, it is reasonable and intuitive to understand the similarity. We have effectively a sort of stable hyperparameter value. Instead, if we move, for example, in core 50, I noted in the empirically that this result, the hyperparameter change with different, we can say with different variants. So even if we not measure directly with the method the similarity, empirically I have validated this essentially, the importance of the dissimilarity in the task improve the performance, but also at the same time speed up the HPO, because work around an interval very near. And yeah, anyway, Fanova helped to implicitly to find this, essentially because if an AP parameter have a great impact, have a great final quantitative value, no? And of course, have to change this.
Great, thanks for the answer. I believe we are in time for the break, but if anyone have any question, I believe someone has a question in the Q&A for Rudy. But if any of the attendees has one question, I believe we have time for one question. Going one, going two.
There's one in the chat, I think.
Yes. Okay, maybe I can ask the question for you, Rudy. So first, Rudy, for the presentation, can you explain the HPO method did you use in the examples you showed? And did you try to it for lower SGD learning rate for comparison?
Yes. Okay, I read the answer now. Okay, essentially in the stochastic, in the experiment that I show you, essentially I propose as HPO Bayesian optimizer, and stochastic gradient descent is as optimizer, and yeah, method using the example did you try to lower comparison, and the other, okay. Okay, maybe I don't understand really the answer. Sorry, the question. Sorry.
Maybe we can ask. I believe it was Hamed. If he wants to raise his hand, so we can maybe unmute him.
If I understand the question, the main point was to understand which HPO method. I don't know if there is a name.
Oh, okay.
Of the method. I guess that was the main point, if I understood correctly the question.
Okay, I understand right in this case. Yes, Bayesian optimization in particular, simple Bayesian optimization. And I also explore other solution, but mainly Bayesian optimization with hyperband, for example. That is a variant of Bayesian optimization. Also, other approach, for example, population-based method, but I not find real good results. So my focus is on the Bayesian optimization family methods.
Great, thanks. So with that, we thanks all the panelists today, all the speakers. And with that, we finish the first session of our ContinualAI Unconference, and we will have a quick break, I believe 45 minutes, and we will come back with more keynote speakers, talk, and hands-on session. So thank you, everyone.